Hello everybody, I'm Dan. Welcome to my Java tutorial series. Throughout my tutorials I will teach you Java using just Notepad and the command prompt. The order in which my tutorials are organized on both my website at javacjava.com and my YouTube playlist is designed to maximize learning by building on concepts from prior tutorials. This tutorial is about overriding the hashCode method. And the hashCode method is in the object class, of course the granddaddy of them all, and I'm also going to explain exactly what a hashCode is. Let's go ahead and open up my website, javacjava.com, and let's click on the Begin button. I'm going to scroll all the way down here to the overriding hashCode method here, tutorial. So the object class contains 11 methods. Over half of those methods are somehow dependent upon other methods within the object class to function properly. In a previous tutorial, I discussed the relationship between the wait method and the notify and the notifyAll methods. Now, one of the most widely used method, equals, shares a special relationship with the hashCode method. At this point, you should already be familiar with invoking the equals method on an object. Now, the purpose of this tutorial is to explain what a hashCode is and how to properly override the hashCode method. So what is a hashCode? Well, a hashCode is a number. And in Java, it can simply be any number that fits into the primitive int range of, this value, negative, whatever that is, to positive, whatever this is. Right? Now, what purpose does a hashCode serve? The purpose of a hashCode is to provide a quick way of locating an object when it is mixed in with a bunch of other objects. That's clear as mud, right? Well, I'm gonna clear that up for you here today. And by the way, hashcodes can in fact be negative. There's nothing wrong with that. Without realizing it, we use hashcodes all over the place in everyday life. Now imagine you have a craving for a can of Coke, so you head over to the grocery store to get one. Now when you step into the grocery store, you're presented with a bunch of stuff for sale. Now that stuff is comprised of thousands of objects, probably tens of thousands of objects. A six-pack of Coke is an object, and it is a specific object that you are searching for amongst a sea of other objects. So where do we begin? I got a little typo there. Where do we begin? Well, we just start walking around, hoping to stumble across it, and we will locate it eventually after some time has elapsed. Now, wouldn't it be nice if we knew what aisle Coke was on to narrow our search down? Welcome to the beginning of a hashCode. Now we can look up at the store directory and we can see that soft drinks are located on aisle 8. We just saved ourselves some time by skipping 7 aisles and going directly to aisle 8. 8 is the hashCode for our 6-pack of Coke object. Okay, we just saved some time and took a shortcut directly to the aisle that Coke is located on. But there are hundreds of objects in this aisle, so now what? Well, we know that a can of Coke is red, so we will narrow our search down to only red items. Now our hashCode is now 8 red. As we begin walking down the aisle, we only pay attention to objects that are red, but can we narrow it down even more? Well, yes, we can. To state the complete obvious, a can of Coke has the word Coke, the string literal, printed right on it. Go figure, right? At this point, our hashCode is now 8 red Coke, and we have narrowed our search results even more. But wait, we are now at a small area that contains not only 6 packs, but 12, 18, and 24 packs of Coke as well. Could we make our hashCode even longer to something like 8 red Coke 6-pack? Well, the answer to that is yes, we could, but we will have a numeric overflow when attempting to translate the hashCode into a primitive int value. You might be going, at this point you're probably going to say, what? All right, well, stick with me here for a second. Now, a hashCode is a primitive int number, and when we overwrite the hashCode method, we can calculate the resulting hashCode using any formula that we can dream up. For the purposes of this tutorial, I'm simply going to substitute ASCII values for each character in the hashCode above. Okay? So 8 red Coke, taking all the characters, 8, and you know what I'm going to do? I'm going to pull up another tab and go to javacjava.com here. Pull up my tutorials menu. I'm going to go to the char data type in case you're unfamiliar. In case you're unfamiliar with the ASCII table, in my char primitive data type tutorial here, I have an ASCII table down here, right? So the number 8 is in fact, decimal 56, right? and then uppercase R, right, is an 82. So popping back over to here, right, R82, E69, D68, C67, O79, K75, E69, right? So just basically translating all of these characters into their corresponding decimal ASCII value. That's my really complicated algorithm there, okay? So that equals this big number right here. All right, we have a problem now because our hash code is much too large to fit into a primitive int value, so we have to truncate it to fit, right? So that when I came up here and I said, could we make our hash code even larger to something like, you know, this? And the answer is yes, and then we'd end up with a numeric overflow, right? Okay. So basically this long number will become 568269686, which will fit into a primitive int value. Now you can probably see the issue is that our hash code is not unique to only a 6-pack of Coke, right? Because 8 red Coke, and then, you know, if we had a 12-pack or a 18-pack or a 24-pack, they're all going to come back with the same hash code. Now that is okay. As a matter of fact, it's more than okay. It's perfect. There's nothing wrong with that. Hash codes do not have to be unique. That is where the equals method takes over to determine which of the tiny number of objects we have left is in fact the one we are searching for, okay? Now, while we just learned that hash codes do not need to be unique, we should strive to make them as unique as possible. Now let's talk about the hashCode method and the object class. How does the JVM generate hash codes in the object class? In the object class hashCode methods, right? In the object.java source code file, the hashCode is a native method, meaning it is implemented by the native code in the JVM. Only a few select individuals have access to that source code, so I can only make an educated guess based on the documentation, right? The documentation states, as much as is reasonably practical, the hashCode method defined by the class object does return distinct integers for distinct objects. Now this is typically implemented by converting the internal address of the object into an integer, but this implementation technique is not required by the Java programming language. In Java, unlike C and C++, we cannot locate the actual memory address allocated for the object. That is privileged information that the JVM will not give up, okay? When we override the hashCode method, we are left to our own devices to come up with a formula for the hashCode return value. Now, does this give us carte blanche for doing whatever we want? No. Our formula must adhere to one of the following rules, and these rules are taken directly from the object hashCode documentation. Here's the Java documentation up here for object. And let's see, let's click on hashCode here. So basically this is taken verbatim from right here, okay? And this will all make sense here. And this is just what we went over before there, where it's talking about how this particular hashCode method from the object class typically converts the internal address, the memory address of the object into an integer, okay? All right, so let's move on here to these rules. I'm just gonna read these rules and come back to them throughout the source code demonstration. So whenever it is invoked on the same object more than once during an execution of a Java application, the hashCode method must consistently return the same integer, provided no information used in the equals comparisons on the object is modified. This integer need not remain consistent from one execution of application to another execution of the same application. Okay, and I'll explain all that there. Okay, if two objects are equal according to the equals method, then calling the hashCode method on each of these two objects must produce the same integer result. And I'll go over this as well. Now it is not being the keyword, required that if two objects are unequal according to the equals method, then the calling hashCode method on each of the two objects must produce distinct integer results. However, the programmer should be aware that producing distinct integer results for unequal objects may improve performance of hash tables. And I'll go in and I'll show you that here too as well, what they're talking about there. And they make it a little confusing by saying not two objects and then unequal. It's like not unequal. It's like, what are they talking about? But I'll go over all this stuff in great detail here. Okay, now do you remember how I started off this tutorial with this this right here, over half of those methods are somehow dependent upon other methods within the object class to function properly. Well, this is one of those catch-22 situations. You will need to understand the rules for overriding the equals method in order to understand overriding the hashCode method. On the flip side, you will need to understand the rules for overriding the hashCode method in order to understand overriding the equals method. I chose to begin with the hashCode method instead of the equals method override, but you will need to watch both tutorials to fully understand the relationship. All right, let's go ahead and dive right into this. Let's come down here and highlight all this source code. Control C to copy, or right click and select copy. I'm going to move my browser off screen. I've got a shortcut to the command prompt on my desktop, but if you don't, you can create one really fast by right clicking, selecting new shortcut, CMD next, and, oh wait, hold on. Right clicking, new shortcut, CMD next, and finish, okay? Just that easy. Let's go ahead and open it up. If you're just coming into my tutorials, you're new to them, first thing you want to do when you open it up is type in javac, which is the Java compiler command. If you should see all this stuff scroll by. However, if you receive an error message, watch my tutorial on installing the Java development kit. You want to make sure you get that installed and configured properly before continuing. CLS to clear the screen. CD space / CD is short for change directory / tells it to go to the root. I'm going to make a directory with the MD command called Java, and I already have that folder, but if you don't, I'll create one for you. I'm going to make another directory here, and I'm just going to call this one overriding hashCode. Okay, let's change directories to the overriding hashCode folder, and I am going to notepad overriding hashCode.java. Okay, Control V to paste. All right, we got a lot of stuff in here, but it's actually rather simple here. What I've got here is I've got two classes, Coke 6-pack, Coke 12-pack. Each one of them have this instance variable called double price, right? And it's not encapsulated or anything like that. It's not private or whatnot. Like it, I really wasn't too concerned about encapsulation on this here. But anyway, and it really doesn't even come into play initially, right? But I've got this constructor here for Coke 6-pack, takes in, of course, the parameter double price, and I'm just setting this dot price, which is this up here, equal to the parameter price value. All very straightforward, but completely ignore these for right now. And they're identical as far as what they do in between Coke 6-pack and Coke 12-pack. All right, so I've got the @override annotation going on here, and here's what we do is we say public int hashCode, right? With no parameters, and then for our method body here, we just simply return 568269686. And if we come back to my tutorial here, that was basically the calculation of this, right? I didn't bother to go ahead and put in all the math, for that, right? I just went ahead and just returned it, right? And I'll go into that in just a moment here, right? So I'm just going to simply return literally this int value, this int literal right here. And I'm going to return it for both of them, right? Because in my example, my hashCode is basically 6 red Coke, and then, that's enough to already overflow our integer value there, right? Okay, so let's come back here, and we're just going to come up here and save this. And then let's see. I got this all out of whack for my alignment for some reason. Anyway, I have to fix that. Make a note of alignment and typo here. And typo, fix those for the final ones there. All right, anyway, so the first thing I'm doing is I am creating, on this first statement here, a new reference variable 6-pack 1 of Coke 6-pack type, and I've got Coke 6-pack 2 and 6-pack 3, 3 reference variables. I'm creating a new Coke 6-pack object, right? And I'm passing it the price of $1.98. And then for Coke 6-pack 2, I'm creating a new 6-pack object. I'm passing it 99 cents. They were having one of these, buy one, get one half off deals, right? So the first one was $1.98. The second one was 99 cents, okay? And then I'm just setting the 6-pack 3 reference variable equal to the object that the 6-pack 1 points at, which is this object right here. And then I'm displaying to the console the 6-pack 1 and invoking the hashCode method, which is from the object class, right? or not from the object class. We've overridden it there, right? Which is the overridden one here, right? And then I'm displaying the hash code from here, and then the hash code there. All right, and let's go ahead and display that. And on the Coke 12 pack, it's essentially the same thing, right? Where I'm displaying those things to the console there. Coke 12 pack returns back that, okay? Let's come up here and save this, and let's clear our screen, Java C. Let's compile this, and let's run this. Okay, now you can see our hash codes are returning back the same value for everything. All right, let's come back here to the rules, right? Rule number 1, whenever it is invoked on the same object more than once during an execution of a Java application, the hashCode method must consistently return the same integer, right? It will consistently return the same integer because we have it set to only return the same integer, all right? So even if it's invoked more than once, we're cool. We're all good on that, right? Now, then this next thing, provided no information used in equals comparison on the object is modified. All right, let's take a second here and not go into that yet. So we're going to invoke the same object more than once in an execution of Java application, and it must consistently return the same integer. Okay. So I've got basically this 12 pack one here. I'm not going to change the price here. Well, you know what? I am going to change the price here real quick there, right? Actually, you know, what I'm going to do is I'm going to move this for loop right up here. And a lot of this is going to look really silly at first, right? But I'm just explaining the rules, and then I'll get into actually what really should be done, okay? So let's clear our screen. Let's recompile this. Hang with me for a moment on that. All right, so as you can see, when we looped through did this for loop there, and we displayed the 12 pack 1 hash code, and we kept invoking the hash code 10 times, it displayed the same hash code to the console. Big surprise, right? Okay, so whenever it is invoked on the same object more than once during an execution of a Java application, the hashCode method must consistently return the same integer, provided no information used in the equals comparison on the object is modified, okay? Now this integer need not remain consistent from one execution of the application to another execution of the application. That particular sentence basically means that, you know, once the application is done, right, you know, basically when we did Java overriding hash code there, right, we get all the same thing there. Now it's done. So we run it again, we get the same thing. You don't have to have that happen, but this thing up there, the hashCode method must consistently return the same integer, right, during an execution of a Java, right? Then it must return the same one. So it has to return the same integer, the hash code in there, as long as provided no information in the equals comparison in the object is modified. Now, if two objects are equal according to the equals method, then the calling hash code method on each of these two objects must produce the same integer result. Now, we'll have to get into my next tutorial to fully explain this particular one there, right? But basically what it's going to say is that you know, if two objects are equal, then those two objects, the hash code must produce the same integer result. And I'll go into that a little bit more on the equals tutorial on that. But in this particular case, basically, for example, we would override the equals like maybe right here, right? And then that should return back the same two as well, okay? So we don't have to worry about that. That's all good as far as we're plugging in just a single int literal return type. So this rule will work 100% of the time. All right, now down to this little confusing thing. It is not required that if two objects are unequal according to the equals method, then the calling hashCode method on each of these two objects must produce distinct integer results. All right, so what that's saying is basically if we were comparing a Coke 6-pack for $1.98 and a Coke 12 pack for $1.98, they're returning the same hash code, right? But now when we override the equals method, one thing we're going to check for, and I'm just giving you a little preview on this, is we're going to check that to make sure that one object is an instance of another object, right? And a Coke 12 pack's not going to be an instance of a Coke 6 pack, even though their price might be equal at $1.99 each, right? The instance of will say, no, the equals will fail out, right? So that's what they're saying in this confusing line right here. It's not required that two objects are unequal according to the equals method. Then the calling hashCode method on each of these objects must produce distinct integer results. So that's not required, right? They can produce the same integer results. That doesn't matter, okay? However, the programmer should be aware that producing distinct integer results for unequal objects may improve the performance of hash tables. Now, I haven't even gotten into hash tables or hash sets or any of that yet, so don't necessarily spend too much time worrying about that. But now let's go ahead and expand this out here. So bottom line, you can override the hash code and return an int value, and that's valid, that's perfect, that's great. It will work, you will break nothing. Now let's go in and let's talk about how we can improve on that, okay? So I am just going to simply take this Coke 6 pack class out, Coke 12 pack class out, and I'm going to bring up our new and improved versions up here, okay? Now they're all pretty much similar there as far as the state, the object state, which is the price there, and then the constructor. And then I've got this method called setPrice, a nice setter, right? Which will take in a price parameter, and then of course it'll change the price state up here, okay? Now, on the override in hashCode, I've just come up with a, just pulled a, lack of a better term, I just pulled a algorithm out of my butt here and just said, okay, let's just return back price times 41 and convert and make sure we make that into, we cast that into a primitive int type. So that's my super complicated private algorithm there for the hash code for the Coke 6 pack now. And for the Coke 12 pack, I basically did the same thing, only times 107, right? So all in all, fairly simple. Let's go ahead and run this up here, right? Let's save this, compile it, let's clear our screen. Compile it, and let's run it. Okay, so now the 6-pack 1 hash code is 81, 6-pack 2 is 40, and the 6-pack 3 hash code is 81 as well, right? Because if you remember up here, 6-pack 3 is a reference variable that points to this object right here. So we get the same hash code back there, right? And then our 12-pack 1 hash code equals $3.72, or equals 372, sorry, and then 159 there for these right here, right? So that's our, excuse me, that's our algorithm to generate unique hash codes for those objects. All right, and then let's talk about our looping thing here where we loop through, right? So one of the rules here was that whenever it is invoked on the same object more than once during execution of a Java application, the hashCode method must consistently return the same integer. All right, so you see that the 12-pack 1, when we first invoked it, it was 372, and the next 10 times we invoked it, it was 372. So we're still abiding by the contract set out here. Excuse me. All right, so the last thing that I really want to talk about here is this little blurb right here. Provided no information used in the equals comparison on the object is modified. All right, so let's say, what does that mean? Okay, we are going to uncomment these two lines. Okay, now on this statement, I'm going to invoke the setPrice, the setter method, and change the price of the 12-pack 1 state to $4.99, 4.99, right? So this will become 4.99, which will affect our hash code. So in essence, we're doing exactly that, provided no information used in equals comparisons on the object is modified. So we're going to modify the object comparisons, right? Because that's the state of the Coke 12 pack there. So when we modify this, then we display our hash code. Our hash code is going to be different. Let's go ahead and come up here and save this, and let's recompile. Let's clear our screen. Java, and let's rerun this again. Okay, so 12-pack, 1 hashcode, 372. We ran it a whole bunch of times, right? And then when we changed its state to 499, right? Then its new hashcode is 533, and that is perfectly valid. That is absolutely 100% perfectly valid. So, and of course, the last line, this integer need not remain consistent from one execution of an application to another execution of the application. So that's kind of goes self-explanatory. If you can follow all of these rules in this sentence right here, then you're good to go. All right, so let's talk about, I don't know, how do you get a unique, let's say, for example, we're thinking about, we want the most unique number to come back for each object, right? The hash code to just produce a unique number. Well, what if we tied it to the number of milliseconds on the current system clock, right? That would return back a unique hash code, correct? Okay, let's try that. So down here in the hashcode method, I'm just going to take this line out here. I'm gonna keep the, oops, wait, where am I? I'm gonna take this line out here and I'm gonna replace it with this commented one. So I'm doing the same price times 41, only now I'm adding the system.current milliseconds, which will basically tack on the number of milliseconds that we got going on there, right? So this is gonna give us a unique number, and I'm gonna go down and do the same thing down here for the 12-pack one here. And there we go. All right, so far so good. Let's come up here and save this. Let's clear our screen. Let's run this. Oh, where do I got, oh. E-turn, how about we return instead of E-turn? Save this, clear our screen. And we'll run it. Okay, so now we've got some hash codes up here, right? And take a look at the 12-pack 1 hash code right here. Ends in 5718, right? Now you can see as we're looping through and we're re-invoking the hash code method here in the loop up here, right? Every time it re-invokes that, it's returning back, well, 5 times the same value. Oop, now our value changed. Guess what? We have now broken one of the rules of the contract. Whenever is invoked on the same object more than once during execution of Java, the hashcode method must consistently return the same integer, right? Provided no information used in the equals comparison on the object is modified. Well, guess what? We didn't right here, we didn't modify any of the information on the object until this little space right down here, right? And then we changed its price there. So technically this should have returned back the same value. So doing something like that, right, will really screw stuff up. I mean, big time, especially when we get into like hash maps and all the hash classes and stuff like that. So that's an example of what not to do. So let's see, I think I've pretty much talked about this, about everything I want to go over on this here. So I'm going to go ahead and just get that off the screen, and leave you guys with some final thoughts here. So now that you have a general idea of what a hash code entails, you are ready to watch my next tutorial on overriding the equals method. Now remember, don't be afraid to just simply return an integer literal if you are not 100% sure that your algorithm will not violate the hash code contract. That concludes this tutorial. Thanks for watching.